Hi and welcome to our today demo, which is about Dpdk or Data Plane Development Kit. As we studied during the course, in the Linux systems, normally the applications which are sitting in the user space, in order to be able to communicate with the networking stack, like network interfaces, physical interfaces or virtual interfaces, they need to talk to the Linux kernel and the network driver that is handling and communicating with the network controller or that particular NIC card. This method may create some inefficiency whenever you are creating some very high performance applications like the packet processing applications and NFV applications like high performance IPS, firewall, load balancer. Dpdk comes to the play and can help us to make a direct communication between the network controller, the network interfaces, and the application. So the application will be able to use the Dpdk libraries in order to directly communicate with the network controller. Not only the applications, but Dpdk also can be used along with the OVS. So we can compile OVS and Dpdk together and build the OVS with Dpdk solution, which is OVS along with the PMD driver of Dpdk, which makes the OVS switch to be able to communicate with the physical network interfaces. So these physical network interfaces, which normally they come through a driver and get connected to the OVS, in this method, we will be presenting directly the network interface through one of these PMD drivers to the OVS. So all of the virtual machines or the containers that are connected to our OVS in the user space, they will be able to communicate directly to the network interface without need to talk to anything in the kernel space with the kernel. All right, so let's have a look at our diagram today. We got the physical server, which is a HPDL 380 generation 5, and this server is hosting an Ubuntu version 16. And we have another physical device here, which is called PC1, and this device is just a network enabled device. We will use it for doing the communication ping testing between the PC1 and the virtual machine which we have here. So within this server, we will have a KVM hypervisor, and the KVM will be running two virtual machines. Both of them are running on Ubuntu 16 and with these two IP addresses 10.10.10.11 and 12. And we will be creating an OVS and Dpdk, OVS Dpdk virtual switch here. We will use the Dpdk version 17.05 and OVS version 2.8.0. We will be creating a virtual bridge called virtual bridge number 0, and we will be adding the two network ports here to the virtual bridge, which is based on Dpdk virtual host user. That's a new type of the network interface, which normally the OVS does not support, but after you compile OVS along with Dpdk, these are the new type of the interfaces which will be enabled for the OVS. So we will create these new virtual interfaces, and we will assign these virtual interfaces to our virtual machines. We will start our virtual machines and we will make sure they can communicate with each other. Then later we will bind the network interface which we have here, the physical network interface. These are the Intel network interfaces which are using the E1000E drivers. We will be unbinding this interface from the kernel. So normally this interface is presented to the kernel as ENS3F1, and we will be unbinding this interface and will connect it to our Dpdk OVS switch. Once we do that, we should be able to communicate from the host one, the PC1 and the virtual machines which we have here. So this communication will happen all over the Dpdk without kernel being involved at all. We will start by downloading and compiling the Dpdk in this machine, and later after that we will compile also the hello world sample application of Dpdk. We will execute that to show you how Dpdk uses the CPU cores. After that, we will be downloading and compiling OVS along with Dpdk, so with the specific switches to compile OVS along with Dpdk. So our OVS will be Dpdk enabled. Once we have done that, we have an OVS, working OVS. We will create a bridge called virtual bridge 0, VBR0, and we will add the two interfaces which we'll be using for the virtual machines, the vhost user 1 and vhost user 2. After that, we will start our VM1 and VM2. These two virtual machines are already created, so the QCOW2 format files are already available. I have created already them. We just create a virtual machine and attach the disks which we have here, and we will start the virtual machine while they are connected to the new virtual interfaces which we created already. Once the virtual interfaces are up, connected to the virtual machine, and virtual machines are booted up, we will do a basic test of connectivity between these two virtual machines. That test will be through our virtual bridge 0, VBR0, and that bridge is served by OVS and Dpdk. Once we have that, these two virtual machines be able to communicate with each other through our VBR0, we will be binding the new PCI interface, the PCI interface ENFS 3F1 to the Dpdk. So we will detach that from the kernel, we will connect that to the Dpdk, and then we will connect that interface to the VBR0, to our virtual bridge in the OVS. So first we unbind it from the kernel, we connect it to the Dpdk, and then after that we connect it to our VBR0. And then we will do a basic test of connectivities between the virtual machines and the PC1, which is the external device connected here. These two versions which we have here, the Dpdk version 17.05 and OVS 2.8.0, these two are compatible with each other. So whenever you're planning to build OVS and Dpdk together, you need to make sure that you are using the two supported versions. So normally in OVS release note, you can find what Dpdk version is supported. So you can first choose your OVS version, and based on that you can find, you know, what Dpdk version is supported, and you can choose the Dpdk version. Let's also have a look at dpdk.org, the website, the official website of Dpdk. So here it gives us, you know, a lot of information about Dpdk, about the project. If we go on Dpdk core, and if we go on documentation, we have documentation, supported hardware. If we just go on the supported hardware, the physical and virtual network interfaces, they are all, you know, listed down here. So these are showing all the network vendors, the chipset vendors that are supported. So for example, Intel E1000, E1000E. So these are the chipset numbers of the Intel which is supported with in Dpdk. Or Cisco, Marvel, you know, all of them are listed here. In virtualized network interfaces, the VirtuoNet, the Chemo is supported, and also the VMware ESXi, the VMXNet 3, that's also supported. Also Hyper-V, and, you know, this one AVP, Wind River Accelerated Virtual Port, that also is supported. So it's not everything supported on with Dpdk, but mostly you can say, you know, a lot of, you know, currently available installed working virtual network interfaces are all supported here. If you go on documentation, the documentation section, it provides programmer's guide and, you know, user guide, API documentation as well. So to start with, we just go on Linux user guide, and here we get all the details of, you know, what do we need to start compiling and setting up the environment for running the Dpdk. It gives us pretty much good information, the basic system requirements. So you need to make sure that the basic requirements are met. And to start with, we just need a machine with the build tools, and also the NUMA, or non-uniform memory access. That library also is required. Also, there is a article from Intel. If you go on the Intel website and find these type of articles about Open vSwitch and Dpdk, they provide pretty much nice overview tutorial that how you can build and build OVS and Dpdk together in different operating systems. Like, you know, this one is with Fedora, you know, you have another one for, you know, Ubuntu, and different stuff are available on the Intel website. So to start with, the prerequisite for the machine is to have all the development tools as well as the packages which has been listed here. NUMACTL is very important. We need to have that. I have already installed all of these tools on our Ubuntu host which we have, and we will start with downloading and building the DPDK. So first, let me go to the Dpdk website. If we go to the download section of the Dpdk, here there are different versions, and we will be using this one, the version 17.05.2, and I will copy the link location. The reason that we are using this version is that after this version, the Dpdk requires the CPUs on the machine to support SSE version 4.2. So SSE is the instruction set of the processor, and the processor which we have on this host, on the host which we are doing the demo, is not a modern processor, so it doesn't support that SSE version 4.2. So we have to use the latest version, which does not require SSE 4.2. So let's start with accessing to our host and continue from there. Okay, so let me SSH to our host 168.200.200 password, and so in this machine I will do a sudo ss because most of the stuff we are going to do is all related to it needs to be executed as root. Okay, so let's create two directories in /opt. We create a dpdk folder, and also we create an OVS folder. So whatever we have related to dpdk, we'll put it in /opt/dpdk. Now let's download the dpdk version 17.05. Let me again copy the link location and put it here. So we got downloaded. Okay, the file is downloaded. Now let me unzip the file, and okay, so now we got a folder for that, cd dpdk stable. Now we need to start compiling the dpdk. So for compiling it, let's go back to the guide, and we can continue from there. So we downloaded the dpdk, we extracted it, and we already in that folder, and we need to create this variable dpdk dir, which will be pwd, the same folder /build. So let's do this part, and then you need to execute this command, make config tx86 64 native Linux app GCC, because you can compile dpdk in different formats, using GCC or ICC, and also it depends on the architecture of the machine. Okay, so configuration is done, and we need to do this set to put the output inside the build config file. That also is required here. Okay, and finally we run the make to compile the dpdk here. So the compile includes the drivers for dpdk, along with all the other libraries of dpdk. Everything will get compiled using this simple command. Okay, so now we have the compile is over. So let's also compile the example. So when we compile the application, by default the examples doesn't get compiled. So I will go to examples, and here are all the examples of the dpdk located. So we use the hello world as the example. So here just the C file is there and the make file. We just run make, and now that is already compiled. Now we got the build folder. If I go inside the build folder, and there is a hello world executable. So if I execute hello world without any parameters, so this is the first dpdk application that we have, and it says environment abstraction layer. So it found 2 PCI devices which are compatible with DPDK. So that's the driver is net E1000 and these are the PCI addresses 000E000 and the other one is 00.1. So we got 2 interfaces and we got hellos from 8 cores. So the processor which we have here, we got 2 processors in this machine and each processor has 4 cores. So DPDK was able to allocate and use each of the CPU cores for using for the application that you're going to build on top of the DPDK. If I do /proc CPU info, so here we got 8 CPU cores. They are Intel X54, 50, and here also we can see actually that was the SSE. So we got SSE 4.1 supported on these processors. But the latest, the versions of the DPDK after 1705, they require SSE 4.2 instruction set. So that's why we use the version 1705. Okay, so now what we have done is we have fully compiled the DPDK, and everything is done in the build folder. So the build folder has been created, and here is all the details, everything, and the kernel modules also has been compiled here. Now let's go back to our guide and we continue from there. Okay, so we finished this part, we finished building the DPDK. Now we will go for the OVS. So we will download the OVS and we compile the OVS along with the DPDK. So this one actually is requires different versions. So let's go to the OVS website for downloading. I just I search download OVS, download Open Virtual Switch, and here is version 2.8.0. This is the version I'm looking for. I will copy the location, go back here, and so in /opt we have another folder called OVS. Let's download that, the package. Okay, the package we got. Now let me unzip it. Okay, and here we go. This is the source of the Open Virtual Switch version 2.8.0. So let's continue now. Let's go back here. So we downloaded the package, we extracted it, and we are already in that folder. We need to export OVS dir, this variable. So pwd just creates the same folder. Adds the same folder, the current folder that we have here. Let me paste it. Okay, and we need to execute the boot.boot.sh, and then we configure with these variables. /boot.sh. Okay, so this is done, and the next one is the .configure with DPDK. So DPDK dir, which we created earlier, that environment variable, and with these flags which are here. So let's do the configuration. Okay, so the config is done. Now we are ready for compiling it. To compile, we use the make with these flags. Let's apply that, and now the OVS is being compiled along with DPDK. So it uses the reference to the DPDK. It compiles OVS DPDK enabled application. Okay, so the compile is done, no errors at all. And okay, now our next step is to do some configuration with OVSDB and starting the OVSDB server. So these are the commands which we have copy and apply there. So let me copy these and paste it there one by one. Okay, so let's get back here, and okay, So actually this kills if there is anything running as OVS, and it starts the OVS here. If we do PS fax, then we should have the OVS DB also saying that, you know, it's running here. Okay, let's get back here. So our OVS DB started. We need to do some configuration for the huge page, for huge pages. So for this one, you need to add these variables, some huge page sizes to the grub, and then you have to build the grub and reboot the machine. So I have already done that, and now after that we need to do this part, just to mount the huge files. Can do this, and let me paste this here. Okay, now we will get into doing the configuration of the OVS and DPDK. So with this part of the configuration, we will be starting the vSwitch-D, which is the main process of the OVS. So let me copy this command here. Actually, this one is the same as the OVS DB, which we started already, but in this guide, because after changing the page file, this machine requires a reboot. You know, they have mentioned this command again because that OVS DB server will get stopped after machine restart. And the other one here is to start the vSwitch-D along with, and this one, all these two also for configuration of the kernel module, which we have here. Now let me copy these and we put them here. Okay, so let's see what we got. So that's it. The OVS DB is already running because we know it's already started. We have that. And here we are getting after starting the vSwitch-D here, we get some information that's okay. So 8 cores in NUMA mode 0. And this is important. The Dpdk info Dpdk is disabled. It is saying that you have to use the config Dpdk init to enable it. So let's enable that. And I think it's better to restart the vSwitch-D also. To enable the Dpdk, I use this command. I call ovsctl set open vSwitch, and the other config is dpdk init is true. Okay, so that is done. Now let's see if that is enabled. Let me let's kill the vSwitch-D. Okay, and let's kill 18920. Okay, so that is completely died, and we run again the vSwitch-D. Okay, now it is saying that Dpdk is enabled, and these are all the other debug logs from the Dpdk inside the OVS. So we started OVS is talking to Dpdk, and these are some informations from Dpdk. It says that, hey, I can see 2 network devices, 2 PCI devices at these 2 addresses. They are Dpdk compatible, and some other stuff, you know, like, you know, I have detected 8 CPU cores, for example, which can be used, and, you know, other information. So now we have our OVS connected to the Dpdk. So we have OVS then Dpdk ready to go. Let's see what is the next step, what we have to do. So we have done this already. Now these are a few settings that, you know, it can be done for limiting the number of the cores that's the OVS can use. But these are in this example actually is for the machines which have many CPU cores. So this machine here, I think it has 2 processors, each one with 14 or 28 CPU cores, which you know, is too much comparing to what we have. So we don't need to make this configuration here. So all the CPU cores which we have, we make it enabled for being used with our OVS and Dpdk. So now we will start with doing the logical configuration and creating a bridge We create OVS, we use OVS CTL, and we will create a bridge 0. Then after that, this is the interesting part, that we use the OVS CTL again to add a port to the bridge 0, which is called, the type of that port is Dpdk user, Dpdk host user, virtual host user. Now, to check that what are the port types supported by the OVS, we can use the command here, that is, it is /utilities OVS CTL get open switch space face type. Okay, so our Open vSwitch now it supports these network type: Dpdk, Dpdkr, Dpdk virtual host user. So Dpdk, this type is for the physical interfaces that will connect. Dpdk virtual host, these are the virtual interfaces, and we got other interfaces also supported by our OVS. But if you compile the OVS, standard OVS, it does not support any of these Dpdks. So now we can use we can create our virtual bridge and we can continue from there. So let's go back here, and we can actually copy all of this, just direct. OVS CTL, add a bridge 0, set bridge 0 data path, type netdev, and create a port inside the bridge 0, called virtual host user 1. Set interface virtual host user type Dpdk vhost user, and another one here. If I call OVS CTL, just say show, and it shows me that we have a bridge 0, and bridge 0 has got a port called vhost user 1. The type of that port is Dpdk virtual host user. So we have already created our, if we go back here, we created the virtual bridge 0. We added these two interfaces to it, and now we are ready to launch our virtual machines to see if we can communicate between the virtual machines and okay, so to start the virtual machines, I have already prepared the commands here, that we will use the Demo system. We assign 1 GB of memory to each virtual machine, so we have 2 virtual machines here, and this one is using vdisk virtual machine 1.img. So this is the hard drive image of this one, and this one is VM2. So 2 different virtual machines are running here. And another important thing we have here is that for the networking device, we are telling that you have to go and use /user local var run open vSwitch vhost user 1. So that's the socket for the network, and the network device for this virtual machine is called vhost user, and it has to be created and added as a virtual IO net PCI with this MAC address which we have here. And these are related to the memory and the huge pages that we had. And also I have added the VNC to start at port number 5901, and this one starts at another VNC port, so we can have VNC to these 2 virtual machines. So once I start, this will be on the command line. We need to create, let me add 2 more. We can start the first one here. So this is the first one. Let me create another shell. Okay, and just run everything as root here, and this one. Okay, so the 2 virtual machines are they should be booting up, we can access them from the VNC. So I have a VNC client here, and I have already configured two destinations on the same host, 192.168.200.200. Now port number 5901 and 5902. So 5901 should be our VM1, which now we have Ubuntu VM1. I can log in as myself, and if I do if config, it should show me. So we got the interface, and the IP address of that interface is 10.10.10.11. Now we have both VM1 and VM2 here in our VNC. Let me log into VM2 as well, and let's see. So we got this one also on the VM2 with the IP address 10.10.10.12. So if you go back our virtual, in our drawing, we have 10.10.10.11 virtual machine 1 and 12 as virtual machine 2, both connected to the virtual bridge there. And now here, let's see if we can access between these two. So these two are connected to our virtual bridge, to the OVS. So let's see, from virtual machine 2 is ping.10.10.10.11, which is able to ping. So this ping, the traffic is going all over inside the OVS Dpdk, and from there is being switched to the virtual machine 1. That's what is happening now. Okay. So we already built this part, and we did the test of connectivity between VN1 and VN2. Now we need to provide some physical access to these virtual machines to use the Dpdk and use this NIC without going through the kernel and drivers to direct access to the PC1 here. So let's try to do that now. Okay, now since we have these two shells are busy, let's create another shell and the access to the server. Okay, and let's go to our Dpdk directory. Dpdk and Dpdk stable. Here we got a folder also called user tools, which are full of few Python files which are helping us for doing the binding, and also the setup also is like a wizard thing that you can use it for building the Dpdk as well. So this is also something easy that you can use. So let's start with Dpdk dev bind. So dev bind is a utility for binding the interfaces from the kernel, so taking it out of the kernel and connecting to the Dpdk. So let me call that user tools and Dpdk dev bind. So if we call it with -- status, this one, it gives us information about the network devices using the kernel driver. So right now we have 4 network devices. We have 2 NetExtreme. These are Broadcom physical network interface. These are the onboard of the server. And we have these 2, which is Intel 82571 network interface, which uses the driver of E1000E. These 2 are using BNX2, and let's see if the BNX2 is also supported or not. Go back here to the Dpdk website, go on supported hardware. Broadcom BNXT is supported. I don't know actually, is it the BNX2 also is supported or not. So but anyway, so our Dpdk also only reports these 2 interfaces are available. If you remember, when we run the Hello World application, it reported these 2 interfaces are supported by the Dpdk. So what we'll do is that, right now these 2 interfaces are in the kernel. They are ENS F0 and ENS F1. If I do an IP link here, you'll see that we have ENS 3F0 and ENS 3F1. Both of them are presented here. These 2 are the Broadcom interfaces, ENP3S0 and ENP5S1. and these are the virtual bridge. This is the bridge 0 OVS netdev, and this is a default virtual bridge interface which is there. Okay, so now let's start binding the interface that we are looking for. So we are looking for binding the interface 1 ENS3F1 to the DPDK. So for doing that, we call same command with, call it -- bind equal to uio underscore PCI generic. Now we have to put the PCI address of that card. So the only identifier we use is the PCI address, which is this one. And okay, so it didn't work. Let's see. Okay, so this error, it might be related to the kernel module, to the UIO PCI generic. That's the driver which the DPDK uses. Let's see. In our LS modules, the latest one is the loaded one is Open vSwitch. Let's strip UIO. Yeah, there is no kernel module. The kernel module is not loaded, so we have to load the kernel module for UIO. This one, the UIO PCI generic, this version kernel module has to be loaded. That's a UIO underscore PCI underscore generic. Okay, now the kernel module is loaded, and let's try to check what's our current status. Okay, so now our network device actually jumped to other network device because we couldn't make it successfully. So let's take this one back into the kernel. So taking that back to the kernel, we can use the same bind command and just specify the driver. So E1000E. Okay, so it didn't give any error. And let's see. Yeah, so it's back here. So all of our interfaces are currently under the kernel driver. Now let's do this again and assign this interface to the DPDK. So we call this with UIO underscore PCI underscore generic. Okay, no errors. That means that the kernel module is working. And here we go. So now our interface is in the network device using DPDK compatible driver. So this network interface now is in the DPDK user space world. And if I do IP link, sorry, we will not be able to see ENSF1. That's gone. So kernel doesn't see that interface anymore. We have ENS3F0, but we don't have ENS3F1. So from the kernel perspective, that interface does not exist, but actually it's connected to the DPDK. Okay. So now the interface is in the DPDK. Now we have to connect that interface to our OVS switch. For doing that, we can use the standard OVS commands for adding that interface. So let's go to our OVS folder. Okay, and we call from utilities cd open switch and OVS CTL. Let's do a show first. Okay, so the bridge is bridge 0, and we call add port on BR0, and the port name is we are going to call it as Dpdk-P0. Okay, dpdk -p0 set interface. That's this description here. We'll call it dpdk -p0 as well here. Now this is important. The type is dpdk, so it's not dpdk vhost. It's just the dpdk, which is the physical interface. Now we have to tell what interface it is. So say options column dpdk-device arguments equal to. So now we have to specify the PCI address of that. What was that PCI address? Here we go. We have it here. So we will copy the full address. Okay, 1 second. Maybe we have done something wrong. Oh, we have missed the equal here. Okay. And we have another error here because I have used equal instead of dash. Okay. Now it is saying that because it's already created, so we have to delete it first, and let's say tell port what is it called, dpdk on the bridge 0 dpdk -p0. Okay, so that's gone, and we call the command. Okay, so no errors. And now here we have our bridge 0. The bridge 0 has two virtual interfaces, dpdk virtual host users, and we have a dpdk 0 interface, which is actually connected to this PCI address. And this PCI address does not exist anywhere in our kernel. So we don't have ENF3F1. That's gone, right? And if we go here, there should be a PC connected here. And if we are able to access to this IP, that means that, you know, that the solution is working, or dpdk is able to provide access, the external access to these virtual machines. Let's go back to our virtual machines now. In the VM2, it's still pinging VM1, and I will ping 100, which is doing it. Yeah. So this host actually is connected through the physical interface, and through the physical interface is coming here. If I remove this interface and we go back here, so that ping is stopped. And once I add that port again back to our, yeah, the ping is started. So if we go back to our drawing, so we managed to connect the PCI card to the dpdk. We take it out of the kernel, we connect it to the OVS, and we did the test of the connectivity. Now if I want to take back again this network interface back to the kernel, I can do that by I can remove that again from the OVS switch. And if I call that command for dpdk stable user tools dpdk dev bind, so first -- status, and it shows us that this interface is in the dpdk compatible driver, so it's in the dpdk word. We will take it off here and we will put it back in the kernel. To doing that, you will say again -- bind equal to, so it's going to be E1000 E, and the PCI address of that interface, which is this one. There. If I run this command -- status again, now the interface is out of here and it is back on the kernel. It's back on the kernel as ENSF1. if I do an IP link, sorry, now we can see, oh, we got another interface here, ENS3F1. So interface is back on the kernel, so kernel is managing this interface, and by the same command, changing it to UIO generic PCI, we will be able to move this interface on the to the DPDK word. So this was our demo about the DPDK. You know, we did quite lots of stuff. So we will put the URLs and more text of the commands also as part of this demo. So this was our demo about DPDK. For accessing these physical interfaces, just imagine that you are trying to build some application like a deep packet inspection or firewall router or whatever, and you have a 40 gig or 100 gig interface, and you don't want the Linux kernel to do any packet processing here. So you can just directly use the same method for mapping that 10 gig or 40 gig interface which you have directly to your application in DPDK. And you can tune the DPDK in order to do fast processing, fast packet processing. There are lots of tuning options available, and you can just directly use the CPU cores for doing your packet processing and any processing of the DPDK. Even with DPDK, if you look at the Intel examples, they are able to limit the number of CPU cores presented for the Linux kernel, and use the rest of the CPU cores for doing the application processing, for doing the network processing on the DPDK. So there are lots of flexibilities and options available in DPDK for creating this kind of high performance networking applications. So this was about our demo. Please, if you have any question, please you can write it in the forum or you can contact me directly. Thank you very much.